Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss about a very interesting and important topic of vector calculus. The name of the topic is concept of divergence and curl of a vector point function. How we can define a divergence of a vector point function. This is point 1. And other point is how we can also define a curl of a vector point function. In these 2 points, divergence of a vector point function is a scalar quantity, but curl of a vector point function is known as a vector quantity. This is the difference between divergence of a vector point function and curl of a vector point function. Curl of a vector point function is a vector quantity and divergence of a vector point function is a scalar quantity. Divergence is known as a scalar and curl is known as a vector, because in divergence of a vector point function there is dot product. We are using in divergence a dot product, but in curl we are using cross product. So if we are using any place cross product, then we get a vector quantity. If we are using any place dot product between 2 vector, then we get a scalar quantity. So in these both points, divergence and curl, vector function is a vector function. That is common to all. Only product is change. In divergence is dot product and in curl is cross product. So I am going to discuss about this topic in detail, and a scalar point function as well as grade of a scalar point function we have discussed in last lecture. Concept of divergence and curl of a vector. What is concept of a divergence and curl of a vector point function? Vector point function means there is any position in a coordinate system and that position represented by a vector form. In a vector form, the position of any point in a coordinate system, 3-dimensional coordinate system, represented by a vector, then that is known as a vector point function. This is a vector quantity. So now one by one we discuss here. First of all, I want to discuss about divergence. What is the concept of divergence of a vector point function? So now number 1 point, concept of a divergence of a vector point function. What is a concept of divergence of a vector point function? In a divergence of a vector point function, there should be 2 main components which are given as follows. In divergence, basically we want 2 components only. To define divergence of a vector point function, we want only 2 components. Number 1 component is A. A is f is vector. F is any position of a point in a 3-dimensional geometry, and that f is represented by a vector. F is a vector point function. This is the position of a point in 3-dimensional system. Second number is V. V is del. Del is this is nebula. This is represented by nebula. This is 3-dimensional differentiation vector operator. 3-dimensional differentiation vector operator. Del is a three-dimensional differentiation vector operator. Then dot product between these two vectors. Del is also vector. Del is also here vector. This is also represent a vector. So del is I del over del x, dou over dou x plus j dou over dou y and plus k dou over dou z. This is the value of del. Okay. And this f is vector. So what is f? F is a vector. F is f1 I and plus f2 j and f3 k. This is f vector. Three-dimensional vector position. Three-dimensional vector which is represented the position of a point in three-dimensional geometry in the form of vector. So when we define a divergence of a vector point function, then we find two components. First component is vector point function. There should be a vector given. There should be given a vector that is represented the position of a point in three-dimensional geometry. And second one is del. Del is represented the three-dimensional differentiation vector and operator. Then dot product between these two vectors f and del is known as a divergence of a point vector function. Divergence of a vector point function. Now what here del is three-dimensional differentiation vector operator with respect to x, y and z. So we should have knowledge about the order of the dot product. What is order of the dot product? We have some knowledge about the order of the dot product. Which should be first function and which should be second function. Here we want to dot product between del and f, del and vector f. Okay. So be taking dot product del dot f. This is correct. This is correct. But f vector and dot del, this is incorrect. This is incorrect. So here we have some knowledge about the order. Which function should be first and which function should be last. So here we taking dot product del dot f. Del taking first, f taking last. Because del is differentiation operator. Del differentiate the function vector point function f. So we put del first and vector point function is second. So del dot f. This is known as a divergence of a vector point function f. So now divergence f equal to, here this is the value of del and this f is vector point function. So now this is the value of del and this is the value of f, vector point function. We have written in last page f1t I plus f2t j plus f3t k. But not here t, f1. f1 is some function of x, y, z, not t here. Okay. So now here del dot f equal to del f1 upon del x I, del f2 upon del y j. Here is j and del f3 upon del z into k. This is k. So del dot f, this equal to value of del is I, dou over dou x plus j dou over dou y plus k dou over dou z into f. F is f1 f1i plus f2j plus f3k. Taking dot product, this is dot product. So this result equal to dou f1 over dou x plus dou f1 2 over dou y plus dou f3 over dou z. So here is not k, there is not should be k, not should be j and I. I is wrong here. Okay, this is also. So this is correct. This is the divergence f. This is divergence f. Okay, but when we are writing f vector dot del, that is wrong. This is correct. Del dot f is correct. Del is differentiation operator. So this must be first. F is vector function. So f is second. B will dot product between del and f. Then we write del dot f. Del dot f is divergence f. Divergence f means this equal to del dot vector f. This is the formula. Okay, where del equal to I dou over dou x plus j dou over dou y plus k dou over dou z, and f1, this is the function of x, y, z here. Function of x, y and z, not t. T is wrong here. Okay, x, y, z. So f1 I plus f2 j and plus f3k. This is the three-dimensional vector point function where I and j, k are unit vector along x, y, z axis. Here we will apply some formula for dot product between unit vectors given as follows. So here I dot j, vector are different, unit vector, so their dot product is 0. J dot k, this is also 0, and k dot I, this is also 0, because different vectors are there. These vectors are unit vectors and perpendicular to each other. So here we apply formula A dot B equal to this A vector and B vector. A mod B mod cos of theta. So cos theta, theta is 90 degree here. Theta is 90. So A vector dot B vector and this A mod I and mod j and into cos of 90. Cos 90 is 0. So A dot B dot equal to 0. A vector perpendicular to B vector. A vector perpendicular to B vector, then dot product between A and B is equal to 0. Similarly, this formula apply here. I and j, both vector is unit vector. Unit vector means its mod always 1. Its mod always 1 and mod always 1. Mod of I is 1, mod of j is 1 and mod of k is 1. Modulus of I is 1, modulus of j is 1 and modulus of k is 1. So I and jk are unit vectors. But I and j and k and I mutually perpendicular to each other. These vectors are at right angle to each other. So we apply formula here. Then we see that here I dot j equal to 0 and j dot k equal to 0 k dot I is also 0. So here I dot j is 0, j dot k is 0 and k dot I equal to 0. But same vector, dot product between same vector I dot I, j dot j and k dot k, that is 1. So I dot I equal to 1, j dot j equal to 1 and k dot k equal to 1. Because same vector I and I, they have 0 angle between I and I. Both are same. So there is 0 angle between the vectors. Theta is 0. So we apply here A vector and B vector, mod A, mod B, cos of theta. Theta is 0. Theta 0 cos theta, cos 0 is 1. And mod I, modulus of I is 1, modulus of j is 1. Modulus of I and I, both 1. Then A dot V is 1. Now, second point is concept of a curl of a vector point function. We have discussed just divergence of a curl, divergence of curl of a vector point function. But now I want to discuss about concept of curl of a vector point function f vector. What is curl? We want to define what is curl of a vector point function. In curl of a vector point function, there should be two main components which are given as follows. In this topic, we have also two components. Without the two components, we can't define of curl of a vector point function. So first point is f vector. F vector is a vector point function in coordinate geometry. In three-dimensional coordinate geometry, f vector is a position of a point in vector form. Del, second V is del. Del is three-dimensional differentiation operator, vector operator. Del is also vector operator. So here f vector, value of f vector is f1 I plus f2 j plus f3 k. This is vector f. This is del. Del vector is I dou over dou x plus j dou over dou y and plus k dou over dou z. This is the vector point function, position of a point in three-dimensional geometry. This is a del, three-dimensional differentiation operator vector. Three-dimensional vector differentiation operator. Okay. Then cross product. Taking cross product between these two vectors, f and del, vector f and del vector, is known as a curl of a vector point function. Be taking here cross product. Main is important this here. In last topic, we have taken dot product between del and f, but now here we will take cross product. If we will take cross product, then this point convert in curl. If we will take dot product, then this point convert in divergence. But divergence always be a scalar quantity, but curl is always be a vector quantity. So now curl f represented by del cross f. Curl f vector. This is curl del cross f. Del cross f. This is I dou over dou x plus j dou over dou y plus k dou over dou z. And f1 I plus f2 j plus f3 k. Now this equal to, this is represented by determinate. 3 cross 3 determinate. So here I am writing I vector, j vector and k vector. Here taking dou over dou x, this is the coefficient of I of first vector. This is the dou over dou y, coefficient of j, coefficient of I, coefficient of k, dou over dou z. And here is f1, f2, f3. So now, after opening this is opening here, I vector. So this cancel and this cancel. This minus this. Dou f3 upon dou y minus dou f2 upon dou z and minus j. Second, this cancel, dou f3 over dou x minus dou f1 over dou z plus k. This cancel, dou f2 over dou x minus dou f1 over dou y. This is the solution. Del cross f. This is known as a curl f. Some problem based on divergence and curl of a vector point function vector r. So here I am solving some problem based on these two topics. Topic is divergence and curl of a vector point function. Okay. So now problem 1 is, this is very easy problem. If vector r, this is vector r. If vector r is this, xi plus yj plus zk. R is given. R is vector point function. R is position of a point in three-dimensional geometry. I am telling you this. This is x-axis. This is y-axis. This is z-axis. Okay. This is the point. Position of a point. Position is x, y, z. Clear? Now, this is I vector along x-axis, j vector along y-axis, and k vector along z-axis. I and j, k are three unit vectors which are applying along the x, y, and z-axis respectively. So now this is the position. So OP, this is origin, meeting O to P, OP. So what is OP? OP is R. OP is vector R. So vector R, how we can make this? First of all, this is point A. This is point A. This is x distance. Some distance cover on x-axis. Then this distance cover on y-axis. Y. And this distance cover on z-axis. This is point P. This distance cover on z-axis. So this is z. So now OP, this is P point. Okay. This is A, this is B, and this is P. So here OR, OP vector, this is equal to vector R. This is equal to OA, vector OA, plus AB and plus BP. So this is X, I, plus Y, J, and plus Z, K. This is the vector R. Then here show that divergence R. We want to show here divergence R. This equal to 3. Divergence R. So now solution here. Divergence R vector. Divergence means here I dou over dou x. Value of divergence means del dot R vector. Del dot R. So del dot R means del value of del I dou over dou x plus j dou over dou y and plus k dou over dou z. And into R. R is xi plus yj and plus zk. So now I dot I, here I dot I dot product between I dot I is 1, j dot j is 1. So here is final result is dou over dou x of x plus dou over dou x of y plus dou over dou z of z. So this equal to, this is 1 plus 1 plus 1 equal to 3. This is the divergence R. Divergence vector R is 3. Next result is curl R. Curl R equal to 0. Second problem, curl R vector, this equal to 0. So how we can define here? This equal to del cross R. Del cross R means here I and j and k. We have discussed some formula just now. Dou over dou x, dou over dou y and dou over dou z. Here is x and y and z. Now solving this I, this cancel, dou z over dou y, and this dou y over dou z, minus j, this cancel, dou z over dou x, minus dou x over dou z, plus k, this cancel, dou y over dou x over dou y. Okay, so now here differentiation of z with respect to y. With respect to y only variable, x and z are constant. So the differential of here, now this equal to, this is curl R. Curl R equal to, here I and here 0 minus 0, minus j 0 minus 0, plus k 0 minus 0. So curl R equal to 0. This is the problem. Now next problem depend on this topic, that is problem 2. Find the divergence and curl of the vector where vector v is this. Vector v is xyzi plus x square yj plus xz square minus y square zk. We will find here divergence and curl of a given point vector point function b in this problem. So now first solution. We know that del differential, three-dimensional differential operator vector. So value of this is I, 2 over dou x plus j dou over dou y plus k dou over dou z. This is given, already given, this is formula. And next b vector is given. B is x y z I and plus x square yj and plus x z square minus y square z into k. Okay, so here this is capital B. Here b vector point function is given and del is the three-dimensional differentiation operator vector. So now number 1 point, divergence V. Divergence B vector. This is vector. Divergence B vector equal to del dot B vector. Del dot B vector. So del is this. Del is I dou over dou x and plus j dou over dou y and plus k dou over dou z. This is del dot, and this is vector v. This is vector v. So now I dou over dou x and plus j dou over dou y plus k dou over dou z, and b x y z I plus x square y j and x z square minus y square z k plus this is k. Okay. So now here dot product. Here is dot product between these two components. We are applying here dot product. This is del, and this is vector v. This is vector v. So now after taking dot product, be writing this type here. This is divergence of v. This equal to dou over dou x of x y z and plus dou over dou y of, this is second coefficient of j. Coefficient of j is x square y and plus dou over dou z. Here coefficient of k. Coefficient of k is x z square minus y square z. I dot I is 1. Here I dot I is 1. J dot j is 1. J dot j is 1 and k dot k is 1. So now differentiating first term. First term is x y z. Here x y z with respect to x. So y z is constant. So y z is taking common. Differentiation of dou over dou x with respect to x plus here y differentiating with respect to y. So this function is constant. X square is constant. Dou over dou y of y plus here x is constant. X is constant. Dou over dou z with respect to z of x square, and y square is constant minus y square dou over dou z of z. So now here differentiation of this is 1. So y z and plus differentiation of this also 1 x square. Differentiation of this x into 2z minus differentiation of this 1. So this y square. So yz plus x square plus 2xz minus y square. So this answer. This is the divergence v. Divergence of v. If value of the position is given in our question, suppose in constant form, then putting the value of x, y and z here. After finding this, then we get divergence of v in constant term. In this question, second point is curl of a vector point function. Now we will find curl of a vector v. So point 2 here. This is point 1. Now 2 point. We will find curl of a vector point function v. So here curl v. Curl v means del cross b. Del cross b I vector, j vector and k vector. We find out cross product by determinate. 3 cross 3 determinate. So I am making here 3 cross 3 determinate. 3 cross 3. So here first row, in first row I am writing unit vector ijk. Second row I am writing here dou over dou x and dou over dou y and dou over dou z. And third vector I am writing coefficient of I x y z. Coefficient of j x square y. Coefficient of j k, this is x z square minus y square z. Okay. After solving this, we find curl v. This is equal to curl of vector b. That is del cross b. Del cross vector b. So now this equal to C curl v. Curl v equal to, here first of all I am writing I, and in bracket open this determinate. First row and first column cancel out. Del this. So now differentiating dou by, here dou by over dou over dou by of, here this, what this, xz square minus yz, y square z, xz square minus y square z, and minus j minus this cancel, this minus this, minus dou over dou z, here dou over dou z of, in bracket second term x square y, here is x square y, this cancel, and plus minus j, second, minus j means second row and second column, second row and first row and second column cancel, first row and second column is cancel, then dou over dou x of bracket xz square minus y square z, and minus first row, second row and second column, first row second column cancel, then multiply this to this, minus this to this, dou over dou z, and in bracket x y z, this is dou z. Now last is plus k, here is first row and third column cancel, third column first row, then multiply this dou over dou x, here dou over dou x and x square y, and minus dou over dou x square y and dou over dou y x y z, dou over dou y here x y z. Now after solving curl b vector, we find this, differentiating this function with respect to y here, here is no y, so differentiation of this result is 0, but here is y square, differentiation of y square is 2y, so here is 2 by z, minus 2 by z, and here is z, here is no z, in this function no z, so differentiation is 0, and first differentiation is 0 now, and here is I is identity vector, minus j, next here is x, in this function is x, differentiation of x is 1, so here is z square, and here is no x, so here is 0, and minus here is dou over dou z, so here is x by z, differential of z with respect to z 1, so here is xy, and plus k, is this, differential with respect to x, here is x square, so 2xy minus, here is z, only xy. So final is curl v is equal to I vector, so here is minus 2 by z, minus 2 by z, I, and second j is minus z square minus xyj, and last is plus k 2xy minus xy, so xyk. This is answer. Okay. Now problem 3, that is very important problem, which is depend on divergence and curl of a vector point function. So here prove that divergence grade r to the power n. Divergence grade r to the power n equal to this पहला point. So solution point 1 point, divergence grade r to the power n, this equal to must be n into n plus 1 r to the power n minus 2. So what is r? R vector is xi plus yj and plus zk. Okay, this is the value of r, but r equal to only, this is vector point function, r is the vector point function, but this is r square equal to x square plus y square plus z square. This equation 1 and this equation 2. So now first of all, first we find grade r to the power n. What is grade r to the power n? This is vector quantity, grade of r to the power n. So this result is del dot r to the power n. Del dot r to the power n means del dot r to the power n. So we have dou over dou x r to the power n plus dou over dou y r to the power n, dou over dou z r to the power n. Here is I and here is j. This is vector quantity. So I am solving here like this. This is del dot r to the power n. So del is I dou over dou x and plus j dou over dou y and plus k dou over dou z and into r to the power n. So this taking inside, then we get here I vector dou over dou x r to the power n plus j dou over dou y r to the power n plus k dou over dou z r to the power n. Okay, so differentiating this function with respect to x, then we get here grade r to the power n, value of grade r to the power n. So what answer is? Here is I, differentiation of n r to the power n minus 1 and dou r over dou x plus I and n r to the power n minus 1 dou r over dou y plus j, here is k, j, and plus k n minus 1 n r to the power n minus 1 dou r over dou z. Okay, so now this equal to n r to the power n minus 1 is common. Here is I dou over dou r over dou x plus j dou r over dou y n plus k dou r over dou z. But now what is dou r over dou x? So we know here x square r square equal to x square plus y square plus z square. So 2r dou r over dou x, this equal to 2x. 2 cancel. Dou r over dou x, this equal to xyr. And dou r over dou y equal to yyr. Dou r over dou z equal to zyr. These value putting here n r to the power n minus 1 I here xyr plus j y upon r plus k z upon r. So r is common, n upon r to the power n minus 1. Here is xi plus yj and plus zk. So here is n r to the power n minus 2 and this is vector r. This is grade r to the power n. First of all, we find this result. Now second result is here again divergence of grade r to the power n. Now divergence of grade r to the power n. So this result divergence of grade is we have find out this value n r to the power n minus 2 and vector r. So now divergence of this function we write here again del dot n r to the power n minus 2 into r. So n is common, taking out in bracket del I dou over dou x plus j dou over dou y plus k dou over dou z and dot here r, here x into r to the power n minus 2 I plus x, here is y plus y r to the power n minus 2 into j plus z r to the power n minus 2 into k. So now taking dot product, finally we get here n dou over dou x of in bracket x into r to the power n minus 2 and plus dou over dou y x in y into r to the power n minus 2 plus dou over dou z x z into r to the power n minus 2. So differentiating this function by product formula, then we get final result. So now here n is common, apply product rule. First of all differentiation of x, then we get r to the power n minus 2 plus x is constant, here n minus 2 r to the power n minus 3 and dou r over dou x plus similar here y n minus 2 r to the power n minus 3 and dou r over dou y plus z n minus 2 r to the power n minus 3 dou r over dou z. Now putting value of this here, then we get here divergence of grade r to the power n. So this equal to here n is common and in bracket. So what result here? R to the power n minus 2, यहाँ भी r to the power n minus 2 plus r to the power n minus 2 and plus r to the power n minus 2. So we write here in bracket 3 r to the power n minus 2. Now plus In this term, x plus x n minus 2 and r to the power n minus 3 into x by r plus by n minus 2 r to the power n minus 3 by r plus z n minus 2 r to the power n minus 3 into z by r. Okay. So now this equal to divergence of grade r to the power n, this equal to n into 3 into r to the power n minus 2 plus here x square and y square, z square. So x square plus y square plus z square. And n minus 2 is common and other result is r to the power n minus 4. Okay. So this is r square. So now here n into here 3 and r to the power n minus 2 plus here is n minus 2 and r to the power n minus 2. This is r square. I am writing here into r square. This is r square into, this is value of r square, n minus 2 into r to the power n minus 4. So final is n into 3 r to the power n minus 2 plus n minus 2 r to the power n minus 2. So here n into 3 plus n minus 2 r to the power n minus 2. So n into n plus 1 into n into n plus 1 into r to the power n minus 2. This is the answer. Okay. Now we want to this last problem on this topic. This is also very important and very short problem. So in this problem we want to discuss about, show that the vector field of this is vector is given to us, is a rotational vector as well as same vector, this is solenoidal vector. So now number 1 point, if given vector is irrotational, then del cross f, this condition verify. If this condition is verified, then function is irrotational vector field. Then function is irrotational vector field. So here we discuss this. Here I and j and k. Here dou over dou x, dou over dou y and dou over dou z. Here x upon r cube, y upon r cube, z upon r cube. This must be equal to 0. We prove this result 0. If this result is equal to 0, then function is irrotational function. So now we define this. After opening this determinate, then we get this value. Here this equal to del cross f. Thus del cross f is equal to I is common vector. Now first row and first column is cancel. Differentiation dou y over dou over dou y of, dou over dou y of, here z upon r cube, z upon r cube minus dou over dou z, y and z, dou over dou z upon y upon r cube, y upon r cube This is n plus j minus j cap. So now here first row and second column is cancelled. First row this ijk cancel and first column. So this one dou over dou x of here is z upon r cube minus by is cancel dou over dou z here is x upon r cube and plus k cap. So first row and third column is cancelled. After cancel out first row and third column, then we get here dou over dou x by upon r cube minus dou over dou y x upon r cube. So now differentiating this formula here. So this equal to, after solving here I cap, now this r cube means r taking numerator minus 3. So here is z is constant. So minus 3z upon r की power 4 and dou r over dou z, dou y. Similarly here y constant. Differentiating with respect to z to r cube. So here is minus 3 by r to the power 4 upon 3y upon r to the power 4 dou r over dou z and minus j. So here dou over dou x, z is constant, minus 3z r4 and dou z over dou x, dou r over dou x minus, both are negative but this positive here, this negative and this positive. So now next here differentiating with respect to x, 3x plus 3x and dou r over dou z upon r to the power 4. Next plus k and here this minus 3y dou r over dou x upon r की power 4 minus plus 3x dou r over dou y upon r to the power 4. So now we see that here this term 3x del r over del y, 3x, next 3x del r over del y. So after finding this value, r की power 4 is common and r differential of this here. So now here I in bracket, writing here minus 3 r की power 4. Next result, this is irrotational vector r, del cross vector, what is vector? Del cross f vector, this equal to, so here I cap and in bracket upon r की power 4. Now what common here? Common is del r over del y, del r over z. So r की minus 3z, this is y upon r. Here is minus 3z, here y upon r, minus 3z, this y upon r की power 4 is common and here is z upon r plus 3y z upon r to the power 4 is common, minus j upon r to the power 4 in bracket here next bracket, minus 3x upon r, minus 3xz upon r and plus 3xz upon r, and this term cancel by this term cancel by this. Similarly in k term is here x upon r minus 3y x upon r plus 3 by 3x by upon r, and this term cancel this. So del cross f, this equal to 0. So del cross f is 0. F is 0. So given vector point function represent irrotational vector. Okay. Now next, what is solenoidal vector? What is solenoidal vector? If divergence f equal to 0, then vector represent solenoidal vector. So here given question del dot divergence f. So here del dot divergence f must be 0. So divergence f means del dot f, this must be 0. So now here del I dou over dou x and plus j dou over dou y and plus k dou over dou z dot here f. F is vector r upon r cube. Now in here I dou over dou x and plus j dou over dou y and plus k dou over dou z, and now here x upon r cube I, y upon r cube j, z upon r cube k. Taking dot product here taking dot product, this bracket and this bracket, dot product. So dot product between I to I dot I is 1, j dot j is 1, k dot k is 1, I dot j 0. Here I dot I is 1, j dot j is 1 and k dot k is 1, I dot j is 0, j dot k is 0 and k dot I is 0. So now taking dot product between these two vectors, then we find divergence f. So here dou over dou x of this. Finally we find here dou over dou x of x upon r cube and plus dou over dou y of y upon r cube plus dou over dou z upon r cube. Differentiating this with respect to x here. So x here is 1 upon r cube, x1 and plus x constant. Differentiating this minus 3 r to the power 4, 3 upon r to the power 4 into dou r over dou x. Similarly plus 1 upon r cube and plus y into minus 3 upon r 4 dou r over dou y and plus 1 upon r cube and plus y, here is z, minus 3 upon r4 dou r over dou z. So this result is 1 upon r cube, 1 upon r cube, 3 upon r cube plus, here minus common, 3x, 3y, 3z. Here x upon r. X upon r means minus 3 is common. 3 is common. So in this term, x upon r. So x square upon r4 plus r5 plus y square upon r5 plus z square upon r5. Okay, x upon r. Value of this is x upon r. So x upon del r over del x is x upon r. Del r over del y this is y upon r. Dou r over dou z is this is z upon r. After putting this value here, we get this. This is r square. So here 3 upon r cube and minus 3 upon r cube. So this cancel this. This result must be 0. Okay. So divergence of f vector, this is 3 upon r cube minus 3 upon r cube. This cancel to this 0. So vector f is represented solenoidal. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.